So mosquitoes, malaria, and physics. This is for World of Insects 2022. So the description and the order. So mosquitoes belong to the fly order Diptera. So the average life cycle 2 weeks. This they have 4 stages of development, and that ties into the aforementioned life cycle time previously mentioned above. So the eggs laid on fresh water / puddles, etc. So basically, if you ever left like a bucket of water outside, you might see the mosquito larvae, accumulating. So that's an example. They like that fresh water. Eggs will then hatch into the larvae. So then, at this case, they live at the surface and breathe through a tube that draws air from the interface where the atmosphere and the water meet. So that's how they get their oxygen. So they have like a little tube that they breathe out of, and they kind of hang out at the surface and draw the air from the atmosphere. After a few days, they will metamorph into pupae, which will then turn into an adult within 1 to 2 days. So then at this stage, in the pupae stage, they don't eat much. They don't eat at all, really. So basically, after that 1 to 2 day time frame, the adult will break out of the shell, the pupae shell, and the adult will fly away. So yeah. So mosquito physics. So basically, here are some properties of the mosquito. So the mass is around 5 e to the minus 3 kilograms, so they weigh around 5 milligrams. Their top speed is around 1 to 1.5 miles an hour. Of course, this would be in a no-wind condition. Obviously, if there's a strong wind, the wind could make them basically fly at wind speed. If they're just stationary, the wind could carry them fast. So this is their top speed in a no-wind condition. So this is the SI units equivalents 0.44 meters per second to 0.67 meters per second. The rate that they flap their wings is 800 hertz. I don't know what the range for audible hearing is for humans. I could double check that, but I suppose if someone could hear 800 hertz frequencies, they could hear mosquitoes buzz around. I know flies you could kind of hear buzz around, so I mean flies might have a higher oscillation rate than mosquitoes, so perhaps that's why. I don't really hear mosquitoes, so I think 800 hertz is kind of inaudible for humans. So that comes out to be 48,000 cycles per minute. Yeah, that's actually very high. So for instance, a car engine only does, let's say, 5,000 RPM. So it's amazing that they could flap their wings so fast. And that kind of brought up a question, do they serve as a gyroscopic effect? Because basically objects that rotate or oscillate, things like that at very high speeds, they might have high angular velocity. So the equation, angular momentum, very high angular momentum, because angular momentum is a product of the inertia and the angular velocity. So the angular velocity is 800 hertz. So what that allows an object when it has high angular momentum, it exhibits gyroscopic tendencies, for instance, like a top. When the top spins, you give it a spin, the angular velocity increases, so then it gains angular momentum, and that allows it to kind of stay stationary and gyroscope around. So they will resist kind of changes in motion and whatnot. So they have this gyroscopic effect. So I was curious about that, so I Googled it, and it said, yes, new research suggests insect wings might serve as a gyroscopic sort of use. So that's kind of interesting. Perhaps there might be evolutionary reasons why. Additionally, mosquitoes, when they land on you, the acceleration is on the low end 5.88 meters per second squared, and the high end it's 54 meters per second squared, and that was from this 0.6 G and 5.5 G. This research here from nature.com. So that's actually very high. If a human had to do this every day, and they'd probably really get destroyed. Their bones would probably break after enough time, or they'd get injured or something. So so they have evolutionary adaptations that allow them to deal with this sort of acceleration when landing on objects. So that ties into their long springy legs, which allows them to deal with that. And basically the impact force, correspondingly F equals ma, is 0.03 newtons to 0.27 newtons. So when they land on you, that would be the force that they exert on you when they land. So you could analytically measure this. I guess if you had a scale, a very accurate scale, and had the mosquito land on it, you would measure these sort of readings. Yeah. So these are some mosquito aerodynamics. Basically, mosquito drag coefficient is 0.42. And that drag coefficient I got from here and from this research article. All the calculations I did are myself. I didn't find them online. I did them all myself. All I found was the drag coefficient. So then from the drag coefficient, you could calculate the drag force when the mosquito flies through the air. And the drag force is the force that the air exerts on the mosquito, that frictional force that slows it down. And that was 1/2 times the air density times velocity squared times drag coefficient times area. So I couldn't find much information on the mosquito frontal area. So I estimated it to be 96 square millimeters, which I found from anatomical drawings online. I did some rough napkin math there. So then this, plug them in, you get 1 times 10 to the minus 5 newtons. That's the drag force. And then you could calculate power, which is the drag force times velocity. You get 1.29 times 10 to the minus 5 watts. So this is the amount of energy a mosquito needs to fly. Is 1.29 times 10 to the minus 5 watts, which is, you think about a light bulb, which is 100 watts, or, a toaster is 1,500 watts. So it's very energy efficient. And then some brief calculation. I found that a mosquito draws 5 microliters of blood per bite. So you multiply that by 700 food calories, which is exhibiting in a liter of blood. And you have to convert that from food calories, which are kilocalories, to SI calories. So that's 1,000 calories per food calorie times 4.184 joules per calorie and times 20%. I couldn't find much research on this, but humans, 25% of the food energy humans eat, they could use to exhibit work, like move around and stuff. I couldn't find research for mosquitoes, so I assumed mosquitoes would be maybe slightly less efficient. So I ballparked that at 20%. Obviously, it's not 100%. No system or machine is 100% efficient. So then that gave 2.92 joules. So you divide the 2.92 joules, divide by watts, because a watt is a joule per second. So you divide those two numbers, and you get 226,356 seconds, which is 62 hours. So a mosquito, if it bites you, it could use that energy, that food, to fly for 62 hours. And then I guess once that has passed, it will have to bite another person. And then it gets another 62 hours of time to fly around. This is a hypothetical. A mosquito traveling at 100 miles an hour would require how much energy? You solve, you get 2.22 watts. So that's actually very small, quite energy efficient. So perhaps there's some research we could learn there. And you could see the drag coefficient of the mosquito is 0.42, which corresponds to like a shape like this, which I guess kind of makes sense because mosquitoes are kind of shaped kind of weirdly, and their head kind of looks like that, or their eyes or wings or whatnot. So I guess that's reasonable to assume. Interaction with the environment. Basically, mosquitoes, they have this Plasmodium virus. So the Plasmodium virus has these species such as Plasmodium vivax, malariae, etc. This is a causal agent that they carry. So they carried this virus by the female Anopheles mosquito. Males do not carry the disease. It enters through the secretion of the enzyme to prevent coagulation. So basically the virus, the mosquitoes secrete this enzyme because the blood will clot when they poke a hole in your skin to extract the blood. So they have this enzyme that prevents that clotting factor from doing its job. And then when they secrete this enzyme, the virus is naturally in that salivary that saliva. So that's how it enters into the human. Both the mosquito and human are hosts of the disease. Genetic adaptations has led to the evolution of the sickle cell trait, which is resistant against malaria. So that's the Mosquitoes have had evolutionary effects on humans basically through this trait that has had impacts in our history and etc. Preventative measures. According to the World Health Organization, approximately there are 6 million deaths per year of caused by mosquitoes. So basically, people are doing work with genetically modified organisms to stunt, or genetically modified mosquitoes to stunt growth of this malaria parasites. Um, Other preventive measures include insecticide-treated nets, rapid diagnostic testing, and interdisciplinary work with entomologists, stakeholders, and public health officials to address this public health issue regarding malaria. Conclusion: overall, mosquitoes have interesting aerodynamic properties. Potential applications for study include new drones powered by piezoelectrics. Who knows? Basically, piezoelectrics are these little crystals that vibrate very fast. Basically, if you excite them with electric current, and they vibrate kind of like the wings of the mosquito. Perhaps applications include energy-efficient drone or flight research. Additionally, malaria progress is limited, and despite numerous scientific breakthroughs, i.e. genetic modification, much work can be done on eradication of the virus. Thank you very much for your time, and this concludes the presentation.